Good morning, students. What was learned in the previous class, ma? That was temperature, thermal energy, and what are the effects of thermal energy? What's the unit of thermal energy? Thermal equilibrium. By applying the heat, how to expand the substance? The expansion of solids, expansion of liquids, expansion of gases when the heat it will be applied. So that all that will be discussed in the previous class. And in today's class, we will discuss about the three fundamental laws of gases and then gas constant, and then you have to apply the three laws of gases. You have to frame a ideal gas equation, and then types of two types of gases also you have to we have to learn. Okay, so the first one, three fundamental laws of gases. First one, Boyle's law. The three laws will be completely based on the volume, temperature, pressure. Okay, so volume, temperature, pressure. According to the Boyle's law, Boyle will be giving this law, and then at a constant temperature, volume it will be inversely proportional to the pressure. Otherwise, the pressure is inversely proportional to the volume. Okay, this is the Boyle law. Boyle law tells that at a constant temperature, the pressure it will be inversely proportional to the volume of the any one substance. So P it will be inversely directly proportional 1 by V, and then we ignore that proportional. You have to add one multiplying one constant, that is K by V. That is the constant you have to multiply by ignoring this proportionality, and then PV is equal to K. So PV is equal to constant. This is the Boyle law. Boyle is given by the Boyle. He said that at a constant temperature, the volume of the sphere it will be inversely proportional to the pressure. Our pressure is inversely proportional to the volume, and then P is equal to K by V, PV is equal to K, PV is equal to constant. This is the Boyle law, and this is the law. It will be also called as law of area. And second one, Charles' law. That law I also called law of volume. Okay, this law I also called as the law of area. This is also called as law of volume. Then at constant pressure, volume it will be directly proportional to the temperature. So V by T is equal to constant. Okay, this is the Boyle law. PV is equal to constant. This is a Charles law. At a constant temperature also this law it will be called as the law of volume. At constant pressure, volume it will be directly proportional to the temperature. So V by T is equal to constant. Okay, and third one, Avogadro's law. Avogadro's laws, at a constant temperature, V it will be directly proportional to the number of molecules is present in the substance. So V it will be directly proportional to the substance. So V by N is equal to constant. So N is the number of molecules is present in the substance or any one gas or liquid, anything. So N automatically number of molecules will we have to use the Avogadro's number. What's the value of Avogadro number? 6.023 in 10 power 23 per mole. So Avogadro number is 6.023 in 10 power 23 mole. So Avogadro law is equal to volume, it will be directly proportional to the number of molecules present in the substance. V by N is equal to constant. That is all are the three laws. This is the fundamental three laws. You have to learn thoroughly. I hope that you understood the three laws. So you have to learn thoroughly. Okay. So first the Boyle law, it will be giving with the Boyle. The Boyle law is equal to PV is equal to constant, and Charles law at a constant pressure, V by T is equal to constant, and Avogadro law, V by N is equal to constant. So three laws will be given by each scientist. Okay. Then go for the next one, that is gases. Gases will be classified into two. One is normal gas or ideal gas. Normal gas, ideal gas will be called as a perfect gas, and then gas will be classified into two, that is a real gas. Normal gas is called as real gas. Real gas or perfect gas or ideal gas. Okay, normal gas or real gas, ideal gas or perfect gas. Okay, So the two case of gases will be present in the all over the atmosphere, and real gas means gases in the atmosphere will be the atoms or molecules in the gases, it will be in a perfect finite intermolecular distance or intermolecular force of attraction. ஒரு ஆட்டமும் இன்னொரு மாலிகுலும் பர்டிகுலர் இன்டர்மாலிகுலர் அட்ராக்ஷன்லையோ பர்டிகுலர் இன்டர்மாலிகுலர் ஃபோர்ஸ் ஆஃப் அட்ராக்ஷனுக்குள்ளேயோ இருக்கும். ஸோ ஓகேவா, இன்டர் அட்டாமிக் டிஸ்டன்ஸோ அல்லது இன்டர் மாலிகுலர் டிஸ்டன்ஸோ டெஃபினைட்டாக இருந்துச்சுன்னா that is called real gases. So real gases, the atoms in the real gases will be separated at definite intermolecular distance or interatomic distance. Okay, but ideal gas, we apply the pressure or temperature. Pressure will be reduced and then temperature will be increased. Some gases will be changed into ideal gas because the intermolecular distance or intermolecular attraction it will be between the two atoms or molecules, it will be weak by applying the high heat and reducing the pressure. ப்ரெஷரை ரெடியூஸ் பண்ணியோ டெம்பரேச்சர் இன்க்ரீஸ் பண்ணியோ ஒரு கேஸை ஐடியல் கேஸை நம்ம மாற்ற முடியும். அப்படி பண்ணும்போது அதோட இன்டர்மாலிகுலர் அட்ராக்ஷன் வந்து என்ன செய்யும், வீக் ஆகி it will be formed as a ideal gas. So real gas is a natural gas and then ideal gas is a perfect gas. When the gas will be called as real gas, the intermolecular force of attraction will be in a definite between the atoms or molecules. That gas will be called as ideal gas, real gas. And then real gas, it will be condition of lower pressure and a high temperature will be applied to the real gas, it will be changed into ideal gas. So ideal gas or perfect gas, it will be in the condition of pressure, constant volume, pressure and temperature. So on the basis the ideal gas to be explained. Okay, next we will go for ideal gas equation. Ideal gas equation, we consider one gas. Okay, so consider will be in constant volume and temperature and pressure. So three bases the gas to be considered, and then by applying the three laws in this part, first one is Boyle law. What is Boyle law? Already you learned in this session. What is Boyle law? PV is equal to constant. Okay, and what is Charles law? This is the first equation, and Charles law, V by T is equal to constant. That is the second equation. And what is Avogadro law? Avogadro's law, that is V by N is equal to constant. Okay, that is the three equation. We adding the three equation, we are mixing the three equation, you get something. So how will you mix? That PV is equal to constant, V is there. So PV by NT, PV, P is there, V is there. So PV is equal to N into T is equal to constant. Okay, so mixing the three laws, we will calculate PV, denominator, numerator PV is there and denominator V is a common term. So PV, V will be taken under the three equation. So PV by the denominator part N into T. So PV is equal, PV by NT is equal to constant. So using the three laws, we find out one equation, that is PV by NT is equal to constant. Okay, the N is the number of molecules in the substance. So we consider the mu mole of a substance, and in the basis of Avogadro number also, we are taking mu mole of mu moles in the Avogadro forms, it will be in the lying in a substance. Or substance la mu moles irukku, Avogadro base la irukku. So you multiply mu moles and then Avogadro number. So N is equal to mu into Na. So number of atoms is present in the substance, it will be equal to the product of multiplication of mole of the substance and Avogadro number. So PV is equal to mu into Na into is equal to constant. Clear that ma? So PV by N again T, N T by instead of N, I write it mu into Na. So mu Na T by is equal to constant. That is the ideal gas equation. But the constant, how will you call the constant? That is PV is equal to mu Na T is equal to Kb. Kb is the Boltzmann constant. Constant ke pehla Kb nu podukom. So Kb is the Boltzmann constant. So what's the value of Boltzmann constant? 1.381 into 10 power 23 joule per Kelvin. That is a Boltzmann constant Kb. Okay, Boltzmann constant 1.381 in 10 power minus 23 joule per Kelvin. That is the Boltzmann constant value. Okay. So the Boltzmann constant value you have to apply, and then we have to cross multiplication. We take the cross multiplication. PV is equal to mu into NAT and KB. Okay. So mu into PV is equal to mu NAT KB. Okay. Then KB mattum munala vechirada neenga vechukonga. PV is equal to mu into NA KB into T. So that the whole term will be taken as the term R. Okay. So PV is equal to R into T. So R is the ideal gas constant. Instead of is the multiplication of mole, Avogadro number and Boltzmann constant. It will be taken as a one single constant, that is a universal gas constant, and then ideal gas constant, and PV is equal to RT. What is the value of R? That is 8.31 joule mole per minus 1 Kelvin per mole minus 1. That is ideal gas constant. R is equal to 8.31 joule mole per minus 1 Kelvin per minus 1. So the PV is equal to RT is the perfect ideal gas equation. That is the ideal gas equation. This is called as ideal gas equation. This is also called as equation of state. Equation of state. What's the meaning of that equation of state? Three equations meet in a single state. That is the equation of state. So this equation is called as ideal gas equation, and the state is called as a equation of state. Equation of state means three equations, Boyle law and Avogadro law and Charles law will be mixed to form an ideal gas equation. That is called equation of state. Okay, this is the very important detail. Ideal gas equation is you mixing the three equations. Boyle law PV is equal to constant, and Charles law V by T is equal to constant, and Avogadro law V by N is equal to constant. You mixing the three equations PV by NT, it will be equal to constant. N, instead of N you put the multiplication of mu moles of Avogadro number. So PV by mu into Na into T is equal to constant. So N instead of is the product of mole and Avogadro number. So PV by mu NaT is equal to KB. Constant value is KB. KB is Boltzmann constant. What is the value of Boltzmann constant, ma? 1.381 in 10 power minus 23 joule per Kelvin. And PV is equal to is a cross multiplication mu NaT into KB. Mu Na KB T, it will be taken on the outside. The whole term is considered as one constant R, that is the ideal gas constant or universal gas constant. PV is equal to RT. So R, the value of R is 8.31 joule mole per minus 1 Kelvin per mole minus 1. The all other term, ideal gas constant value is a very important, you have to learn thoroughly. Okay. So ideal gas, this is called as ideal gas equation. There's also it will be called as a equation of state. Why? Equation of state means all the equations, Boyle law, Charles law and Avogadro law all will be lying in a single equation. So that is called as a equation of state. Okay. Then I explained one match and then one book back one word. Okay. In the book back one word, one diagrammatic question is there. So I explained the one match and then one word, book back one word. Okay. This book back one word having one diagrammatic part, that the diagram explain A, B, C, three substances will be contact with one another. What's the base? The heat energy will be transferred. Three hot substances, it will be contact with one another. What the base? The heat will be transferred from one to another. So A, B, C. A substance is having the 300 degree Kelvin, and B substance is having the 304 Kelvin. C substance is having 303 Kelvin. So 303 or 305. 303, 304 and 305. 3 Kelvin values it will be differ. Okay. So what is the base? The heat will be transferred. Anyone say? There always the heat will be transferred to higher potential to lower potential. High heat energy to lower heat energy. High temperature to low heat energy. High value la low ku transfer agum. So idhula edhu high? First, the heat will be transferred to B to A. Okay. B 304 to 303. So B to A. Then C to A. Then C to B. Clear that? Because C is having the high temperature. So the comparable to A to B, the heat will be transferred from B to A. Comparable C to A, the heat will be transferred from C to A. Comparable B to C, the heat will be transferred from C to B. So all options there. You have to tick one correct answer. What is the correct answer, ma? Heat will be transferred from B to A. So B to A. Okay. And second one, C to A. So C to A. Okay. And third one, B to C to B. So C to B. So this is the correct answer. A is the correct answer. The heat will be transferred from B to A, C to A and C to B. Now all that A to B, is it correct? A to B. A having the lower temperature. Will be added, heat will be transferred from low to high? No. So it will be wrong. Okay. Then A to B again. So the heat will be transferred from A to B? No. It will be wrong also. And then heat will be transferred from B to A. This is correct. And A to C? A is 303, C is 305. So heat will be transferred from high to low or low to high? Automatically the heat will be transferred from high to low. So the heat will be transferred from C to A only, not A to C. So this is also wrong. So the right answer is the heat will be always transferred from B to A and C to A and C to B. Okay. This is the one important question in this lesson, in this part. Okay. Then I will explain the one match also. In the left hand side, linear expansion is there. What is linear expansion? When the heat will be applied, the substance, it will be increase, expand in the linear. Okay, length increase and a linear expansion. Then superficial expansion, cubical expansion. Superficial expansion means aerial expansion. So when the heat will be applied to the body, the area of the body, it will be increased, expand by applying the heat. So superficial expansion means area of to change in area. Then cubical expansion means cubical, the full body it will be changed when the applying heat. Then heat transformation is always, already I told, hot body to cold body or high temperature to low body. So the heat will be transferred from higher temperature to lower temperature, hot substance to cold substance, a high heat body to low heat body. Okay. So heat transformation is always hot body to cold body. And Boltzmann constant already explained the previous one. 1.381 in 10 power to minus 23 joule per Kelvin. So, okay, students, now you have to match the left and right part of this question. What is linear expansion, ma? That is change in length. So, first one is change in length. What is superficial expansion? Change in area. That is the second one is change in area. Okay. What is the third one? Cubical expansion. Cubical expansion means change in volume. Okay. Then heat transformation, hot body to cold body. Okay, that is the fourth one. And what is the Boltzmann constant? That is 1.381 in 10 power minus 23. So that all are the easy matches. So you have to first you know that all the concept first, and then you have to match anything, and you have to analyze the book pack questions also. Then you have to learn thorough the full lesson. Okay. So what was learned in this session, ma? First, 3 fundamental laws of gases, and what are the types of gases? What are the types of gases? Real gas and ideal gas. Real gas, the intermolecular force of attraction or atomic force of attraction, it will be definite in manner of between the atoms or molecules in a gas. It's called real gases. Suppose we have to reduce the pressure or increasing the temperature of any one gas, the gas to be changed in an ideal gas or perfect gas. Okay. Then ideal gas equation. First three, you have to take the 3 laws, Boyle's, Charles' law and Avogadro's law. You have to mix the 3 laws, you get the one equation, and after you have to put the constant is Boltzmann constant. After you have to consider the ideal gas constant. Then all of the, you have to easily derive the ideal gas equation. So PV is equal to RT is the ideal gas equation. PV is equal to RT is the ideal gas equation. This is the ideal gas constant. Okay. That the value is 8.31 joule mole per minus 1 Kelvin per minus 1. So this is the very, very important detail. Okay. So today home assignment is learn and write the ideal gas equation. Learn and write the ideal gas equation. Ideal gas equation and fundamental laws of gases. Fundamental law of gases. fundamental laws of gases. Okay. So learn and write the ideal gas equation and learn also the gases. Boiler, Charles, la, okay, thank you.